This video is about a hydroponic light, but it's also, I'm just going to increase the brightness a little bit, about testing the Cat S61, because I originally got the Cat S61 because I thought it would be interesting having a phone that can record video as well as recording thermal imaging stuff. But watch this, there is a problem. If I move my finger backwards and forwards slowly, you'll see that every so often it jerks. It's very jumpy, it's very glitchy indeed. Now, I've tried the native camera app with the Cat S61 and it's unusable for video because I can't find a way to lock the focus, can't find a way to lock the exposure, can't find a way to lock the automatic white balance. It's a very basic app. And it also, because the focus is continually, it's at close range, the focus hunts all the time. See that jumping? That is so annoying. I've tried 2 different camera apps with the Cat S61. It seems to have an inherent firmware problem or even hardware problem that means it's jumpy and jerky. That's not going to be usable unless they find a way to fix that. It's not going to be usable for making technical YouTube videos. That's a bit disappointing. But anyway, the other subject of this is this very mass-produced hydroponic light with this sort of, what they call the full spectrum phosphors. What they mean by that is it's the blue emitter chip. It's got this sort of mixed colour phosphor and it puts out that vivid purpley pink light. And what's nice about this is that it's now so mass-produced, it becomes so standard. It comes in this sort of shelving packaging and comes with lots of helpful information. Energy saving 80%. Loading tungsten lamp. Really? Is it designed to replace a traditional tungsten halogen lamp? Not sure. But it's got various things like the free drive constant current technology, integrated design. The design is simple. Less electronic components are used to reduce the failure rate. That is reasonable enough. Compact, portable, easy to install, more convenient to use, maintain, also accurate. Good heat dissipation design, not so sure about that. Good waterproof performance, okay. High efficiency and energy saving, light efficiency up to 80%. Matters needing attention. When using, the lamp surface will have a certain temperature rise. Belongs to the normal phenomenon. The shell temperature is higher, don't touch directly. What it means is it gets very hot in use, don't touch it. If there is high pressure, it must be grounded. What it's meaning there is if it's a mains voltage unit, which it is in this case, it's 220 volt, then it needs a ground connected, but it does have a ground. Before use, the surface protective film must be torn off. That's reasonable enough. It's all logical. Okay, let's open it up. I've had it open. I've already done some tests. I've not had it lit though. So what we have in here are 2 modules in parallel. They do a 50 watt version and a 100 watt version. This is the 100 watt version. It just seemed logical to go for the high power one. And the listing is full spectrum of 50 watt, 100 watt LED grow light, hydroponic veg flower plant grow lamp IP65. And the price of this, the low power one, the 50 watt, is £5.69 inclusive of shipping. And that was shipped within the UK. And the bigger one was priced at £8.49. £8.49 shipped within the UK. That's very good. I shall leave the cover on. It says peel the blue cover off. Oh no, what the heck? Let's peel it off. I do notice it's trapped under this here. This may not peel off easily. I shall try and pull it off. If it doesn't come off in a hurry, I could pause. That would give me an opportunity to test the pausing function of the camera, which I think does work anyway, so it doesn't really matter. So the fact this is pulled out so easily actually means that the aluminium plates in the back of these aren't really what you'd call super tight onto the back heatsink area, the sort of metal fin that's being used as a heatsink here. Let's see if I can get this one off. Let's see if I can just scratch in and pull this off. Yes, it's kind of just about to peel. So what they've done here, when it says low component count, they really mean it. It is the simplest, it's the very common cob designs. And I'm going to power this up in a moment. I guarantee it's going to flicker. Having said that, I've not tried that with the Cat phone yet. It also has the blue film in the back. Yeah, I'll leave that on at the moment. The unit comes with the grommet just sort of stuffed in, just to allow it to flat pack really. So that can be pulled up to seal in. It does have an earth going on to the crimp here. It's got a crimp and then the rivet through one of the rivets that holds the panels on. Everything is just riveted together, including this little sort of hang bracket. The cable is tiny, but that's very common for these things. Let's bring the hoppy up, and we'll also bring the quick test. The Cliff quick test, and I will actually connect the earth wire. So I think the main thing about these little lights is they've evolved now. Although they are going to be very flickery to the camera, and out peripheral vision, they will flicker. The purpose of these is for growing, well, let's face it, it's for growing marijuana, isn't it? So I've plugged that up. Let's plug this in. And the plants probably aren't going to be too bothered by the flickering. I'm not sure how that goes. So let's plug this in. It's lit up. It's that lovely pink. You can see the flicker. It's horrific. 257 milliamps. It says 60 watts for my 100 watt light. And I expect as it warms up, that's going to go down. Let's gingerly pick this up, shall we? Oh, that is very, very bright. And super flickery. Yeah, the flicker is just what you're going to get because of the way it drives it. There's no smoothing at all. It is riding the sine wave with a large series string of LEDs. So the power is hovering at 60 watts. I would guess that as the power is left on, it will come up to temperature, and then those little chips that are current regulating will start regulating down. But it will waver up and down because it self-regulates according to temperature. It's getting quite warm. I would expect to get quite warm. The power factor is 0.938. That is pretty common for these type of drivers because they have the voltage and current are in sync, although it's not a perfect sine wave, so to speak. Okay, so that is just hovering. It's just sitting at a fairly constant current. I'm guessing that as it heats up, it will get to the point that it will suddenly kick in and going down. But anyway, that's enough flickering. I'll test that later on, and I'll tell you the results of how much it regulated down in free air. Let's get the hoppy out the way with its flickery display. So the circuitry in this is very, very simple. I've already doodled it out. Let's bring the notepad in. It's a very crude doodle. It's a slightly lower class than my normal doodle. The supply comes in and it goes to each of these two circuit boards. I'm guessing they must have dedicated 110 volt circuit boards that probably run pairs of LEDs in parallel. But in this case, because it's a 222 40 volt one, every single LED in this is a single chip and they're all in series. So the supply comes in. Live goes straight to the little bridge rectifier, which is tucked under this blue metal oxide varistor here. Neutral comes via this resistor, which is green, brown, gold, gold. Green, brown, and gold is a multiplier, which is 0.1, so 5.1 ohms. The metal oxide varistor is a typical 471 volt one. That means that when the voltage goes higher than about 471 volts, it will start turning on. Basically, if there's any sort of spikes on the supply voltage, it will clip those down. It will just shunt them momentarily because they're usually at fairly low current. There is a provision for a capacitor, I notice across this, but they've not done it. That if there was, it would have been here in the drawing. I'll just dot it in. The circuitry is such that it's got a 1 megohm resistor across the output of the bridge rectifier. And then the positive goes through all the LEDs in series. There are 68 LEDs times 3 volts each, gives about 204 volts. Now, that's an interesting thing because if this is aimed at the Chinese market where their supply voltage is 220 volts, then it's only dropping roughly about 16 volts RMS, which means that those little chips there are not going to dissipate too much heat. With 240 volts, that makes a significant difference. Suddenly it's at 36 volts RMS, and that means they're going to get a lot hotter. So on the 240 volt supply, it's probably not going to run as bright because it will get hot and self-regulate down because those little chips do have internal temperature sensors. I don't know what number the chips are. I scrubbed the top off this one. I looked at the number and literally, if this is the chip, the number was like loads and loads of numbers along one line, then loads and loads of numbers along the other one line. And because it's been covered in this coating, this sort of gel, it means that it's just impossible to read that. But I'm pretty sure I've come across a similar chip. The pinout is like this. It's 8-pin. All the pins at one side are connected positive, and I'm guessing it's probably actually divided into 2 current regulators. And then the 2 pins are connected to the negative, and then there's a resistor, sense resistor, 9.1 ohm connected between the negative and the other 2 pins. It's odd that they're actually sharing a single resistor. I would have thought they might actually have one resistor for each sense pin, but they haven't. So the path it takes across this circuit board here is the positive comes from this side of the bridge rectifier, and it goes through, if these rows of LEDs are 1, 2, 3, and 4, it goes through row 3, end to end, then a track goes between the 2 rows of LEDs there, and then it goes through row 4, and then a track snakes up right back to the top here. It goes through row 1, track snakes back, goes through row 2, and then goes to the common of all these chips. And all these chips, these current sense chips, there's 3 of them, are just wired in parallel like this. The negative of the output of the bridge rectifier, unsmoothed, no capacitors at all, then feeds the chips. It goes into these 2 pins plus then the resistor to the sense pins. So it really is just the string of series rectifier, string of series LEDs, and then 3 current regulating chips in parallel just to regulate the current down and share the load. In this case, because it's a higher power unit, they've just wired the 2 in parallel. I almost thought they might have actually made a generic 120 volt one and then wired for America and Canada. They could have wired them in sort of parallel, but in the UK they could, and China they could have wired them in series, but they haven't done that. So that is the circuitry. Now I'm going to plug it in and we're going to check it and see what it's like when it's hot, because this camera, this is such a shame that it doesn't record good video at the moment, unless they fix that. It does have the ability to record thermal imaging, so I'm going to try that right now. And this is where the Cat S61 would really come into its own, because it does allow real-time thermal monitoring. So at the moment this unit is quite reflective. I've put a bit of Kapton tape over here to try and act as a sort of thermal target. And if I move the cursor over that, then we're getting a temperature of about 100 degrees Celsius. That's pretty hot. And this unit does get very hot. So I'm going to flip it over very quickly. And this is where the camera is going to smear out a little bit. But the temperature on the front is actually higher. It's round about the sort of 110-ish mark on the front of this. So they do run hot, but that's just the nature of these devices. The LEDs are being pushed quite hard. So I'm going to switch back to normal vision again, and we can just discuss other small details about these units. Back to normal vision. Oh, this is quite hot. So in use, I monitored the temperature for a while, should I say the current, and it did start regulating down a little bit, but it did more or less stay at the 60 watts throughout the whole test. I'm not sure how much that would go in a much longer test. Things worthy of note. The circuit board does have waterproofing. The real reason for the waterproofing is to make it sort of finger resistant. It's to make this as cheap as possible. It is using these surface mount manufactured. I'm guessing the only things that are soldered on manually are the resistor and the metal oxide varistor and the connections. So it is optimized for mass production, and they have flooded it with that sort of gel stuff that protects the circuitry, but more importantly protects you from actually touching it, although I wouldn't recommend that you rely on that as the only layer of insulation. Certainly don't grab hold of the reflector and start dabbing your hand all over it, or you will probably get a harsh lesson. The way they've manufactured this, they've got a little piped dam around the edge, but it's clear that they've taken a large circuit board with several of these modules on the one board, and they've piped around the outside of the whole board, flooded it with this the gel that's used to actually seal. Noting that around the rivet holes they've also put a little dam, and then they've either snapped the boards apart if they were V-grooved, or they've cut them. I'm guessing they probably are V-grooved so that once that's done they can just snap it. Other things worthy of note. It is grounded. The aluminium does have that ground connection. I would recommend putting, if you were using these, I'd recommend locally fusing it at they're typically about 1 amp or something like that. Because as has been discovered, some of these circuit boards, if something does fail and it burns, it can burn through the sort of fiberglass layer, because this is an aluminium sandwich, this circuit board. I have to say, I don't think there's any heatsink compound in the back of that. I'm not seeing any sign of any squishing out. It is relying probably on convection coupling onto the aluminium, perhaps, as well as the contact points at these 4 positions. But it's not really sandwiching tightly on. So I would recommend using an inline fuse on each light, just so that if one does fail, it just takes that one light out and controls the carnage. Fan cooling would help this a lot. It will benefit greatly from forced air circulation in the vicinity, but if it is used in certain applications like marijuana growing, they often use fans because it flexes the plants, it moves them backwards and forwards, and it strengthens the stems because it emulates nature. So the fan cooling would be helpful, but I have to say that over that full test with this, there's a little bit of Kapton tape I put on top for that thermal target. Over the full test, it went up to about 100 degrees Celsius, but the current didn't vary it, but it reached the sort of thermal equilibrium point that's fairly close to its power rating. And another thing worth noticing about these, after I featured, if you got deja vu, it's because I featured another one of these. And someone got in touch with me and said, they don't last forever, but it doesn't matter because they're cheap. They're cheap, and as with any hydroponic type light, they're pushing it quite hard and the intensity will gradually go down. So even if it doesn't last, 1,000, 10,000 hours, then it's a disposable item. It's a case of, it's just like a replaceable lamp. It's cheaper than, say for instance, probably cheaper than a sawn lamp, high pressure sodium. And you have to change those lamps routinely, the high pressure sodium ones they use in commercial hydroponics. Another thing I like about this, the LEDs, in the previous one, which was somewhere in here, not sure that is, in the previous video where I covered the white version of this, they had the LEDs, they had multiple chips inside each LED, and then they had sort of parallel arrangements, clusters. I prefer the fact that they've got one chip per LED, just because it takes the strain off. It means that you've not got higher dissipation inside the LED, although they compensate for that with the parallel LEDs, but then current doesn't always share too evenly with that. In this case, it is a single chip per LED and they are all in series. That does mean that if you get an early failure in one that shows the black spot of death, like a little black dot inside, theoretically, you could just cut around that area and bridge that LED out. You can actually get access to the tracks really easily here. So the bit of preheating, you could, I suppose you could preheat the light by running it and then making sure you turned it off. You could scrub some of the copper, the solder resist away, and then you could solder directly in the pads to put a little link across a dead LED if you did have one fail early on, because that's when they do tend to fail. Other things worthy of note. Yes, this is probably designed for 220 volts. That extra voltage of 240 volts will probably shorten the lifespan a bit with heat. It'll also put a lot more strain in these little regulator chips, which they drop the difference in voltage. They just act like a variable resistor in series of the LEDs. It makes sense then that it might be viable to use a buck transformer with these. The transformer that, say for instance, you've got a 24 volt transformer, you wire it up across the mains, but then you actually put the secondary of the AC output, the 24 volts, in series. I made a video about it. If you search my videos for buck transformer, you'll find it. But it basically either nudges the mains voltage up by 24 volts, which is not good, or it nudges it down by 24 volts, which would actually bring it down to around about the sort of 216, 220 volt mark. And that would mean that these little chips would then not be dissipating so much power, and they would operate at their regulated current, it would reduce the dissipation from the whole panel by that little bit. So they're very interesting. I like the fact that it's become super mass produced. They just accept the fact that it's going to have a bit of flicker. It's not ideal, but that's just the cheapest way to do it, is just to have what is in effect a resistor in series with all the LEDs, which means it's only lit for part of the sine wave. When the voltage of the sine wave actually exceeds the, let me just doodle that. If this is a sine wave coming in, it goes through a bridge rectifier, so then it's full wave rectified DC, but unsmoothed. Each one of those humps, the LEDs won't actually start conducting till about here, so it won't turn on initially. But then they'll turn on, and then when the voltage goes down to below it again, they'll turn off fairly abruptly. And it means that there'll be a very decisive on and off pulsing, and that's what you saw the flicker earlier on. So, yeah, it's nice to see the way they're evolving in such a specialist application there. It's very clearly aimed at the marijuana growing. I mean, the cannabis type industry, but it would also find its use for people just wanting to experiment with growing vegetables and stuff like that indoors. It's nice that they've made a product specifically for that, and it's so popular, that's a bit suspicious, that the price has come down really low. Could have done with a longer flex, but ultimately if you were going to use these, you'd have a sort of proper hang system. You might have a terminal in the vicinity of it for a quick connection, and it would just be geared up to use these. So let me know in the comments down below if you've tried these for growing plants, vegetables, flowers, and just what you thought of them and how long they do actually last. It would be very interesting to know. And that's more or less it. As you've noticed throughout this video, the Cat S61, as I say, that glitching is just very annoying. I hope they fix that, because if they do fix it, well, you can hear the sounds pretty good. Let me show you this. The zoom is just absolutely superb. I do hope they fix that glitching, because if they do, this would be an absolutely perfect recording device for making the videos at the bench. So here's hoping that it's not a hardware thing, that it's maybe a firmware thing. Maybe even I've got a defective unit, but I don't think so, because other people mentioned that while they were gaming, it glitched as well. So I think there is something that's either a memory bottleneck or something glitching in the firmware, something commanding processor time and unreasonably, and just blocking out all other apps while it does that and causing that slight glitch. But there we go, an interesting light indeed.